So, have you ever seen a map that claims to show the blueprint for true artificial intelligence? Well, today we're looking at one. It's this mysterious, really complex diagram that its creator says holds a fundamental secret to, the very nature of intelligence itself. Okay, so let's just dive right in. I mean, at first glance, it's a lot to take in, right? You've got this incredibly intricate, perfectly structured circle. It's just filled with these strange symbols and numbers and all these interconnected lines, and they're all leading to a single point in the center. Honestly, it kind of looks like an ancient mandala or some kind of mystical symbol, doesn't it? But here's the thing. This image, it has nothing to do with mysticism. It's actually deeply, deeply rooted in the core principles of computer science and logic. So that's the big question, right? How in the world do we decode this beautiful, maybe a little intimidating image, and what could it possibly have to do with true intelligence? All right, so to understand the whole map, we've got to crack the code. And that means we have to start small, with just a single piece of the puzzle. And that basic piece is something called a logic gate. The easiest way to think about it is like a tiny little decision maker. It's a fundamental building block in like all digital circuits. It just takes a couple of simple inputs, think yes or no, and based on a very specific rule, it spits out a single predictable output. Super simple. Now, these gates, they speak the language of computers, which is, of course, binary. That's just zeros and ones, right? Off and on. So those four-digit numbers you see all over the diagram, well, that's basically a complete summary of how each gate behaves. It's like a cheat sheet, a shorthand for the gate's output for every single possible combination of inputs it could get. And right there, that's the key to understanding everything else on this map. Let's just take a familiar example, one you've probably heard of, the AND gate. You can see it right there. It has its name, and it's got its own unique little symbol, and then there's its binary code, 0001. You can think of that code as its unique signature, its logical fingerprint. Okay, so now we can read a single symbol. We've got the key, so let's unlock the rest of this thing. We're going to zoom back out now and take a look at the bigger pattern that's at play here. And here is the crucial point. Count them up. There are exactly 16 of these logic gates on the diagram. Not 15, not 17, 16. And trust me, that number is not random at all. It's fundamental. So why 16? What's so special about that number? Well, it turns out that for any system with two simple inputs, let's just call them A and B, there are precisely 16 possible ways you can combine them to get an output. That's it. So this map, it isn't just a random selection of gates. It is a complete, totally comprehensive chart of every single possible two-input logical operation that can exist. It's basically a self-contained universe of logic. And a lot of the gates you've probably heard of fit perfectly into this system. You've got AND, which we just looked at. Then there's OR, which is true if either input is true. You've got XOR, that's exclusive OR, which is only true if one input is true but not both. And of course NAND, which is literally not AND, it's the exact opposite. But here's where it gets really cool. This isn't just a random collection of 16 gates plopped into a circle. The structure itself is incredibly elegant. The geometry is just packed with meaning. Just look at the symmetry, it's perfect. Every single gate on this wheel is placed directly across from its perfect logical opposite. This arrangement isn't just to make it look pretty, it's a visual representation of logical duality. Let's start with the most fundamental opposition of all. Look at the very top. We have something called tautology with the code 1111. This just means its output is always true no matter what. Now look directly opposite at the very bottom. You've got contradiction, code 0000, which is always false. It's beautiful, right? Absolute truth sits directly opposite absolute falsehood. And this pattern holds for every single pair. Remember the AND gate with its code 0001? Well, look directly across the circle from it. What do you find? The NAND gate with the code 1110. It's the perfect inverse. For every single output where AND is a 0, NAND is a 1, and vice versa. It's a system of just perfect balance. Okay, so let's recap. We've decoded the symbols. We understand that this is the complete set of all 16 logic gates, and we've seen the incredible, elegant symmetry of the structure. So now let's circle all the way back to that big, really ambitious title, True AI. So when you put it all together, what are we really looking at here? This isn't just some chart, it's a complete map of a closed logical system. It visualizes all 16 of the fundamental building blocks of computation, and it arranges them in a way that reveals their deep, symmetrical relationships. This, this is the bedrock. This is how every single computer on the planet thinks.
So then, why call it true AI? I mean, that name makes a really bold claim, doesn't it? It suggests that to build genuine intelligence, you first have to have a perfect, complete understanding of the foundational system of logic itself. The idea is that true intelligence, whether it's in a machine or not, has to emerge from these fundamental, unchangeable rules.
And that leaves us with a pretty fascinating final thought. Is this map just a beautiful diagram of computer science? Or is it something more? Is a complete, perfectly structured system of logic the necessary foundation, the first essential step on the long and winding road toward creating true artificial intelligence? Now that is something to think about.